Today is 3.2, and today we talk about composition of functions, which is basically a function in a function, and then decomposition of the functions, which is breaking down a big, scary function into two separate functions. All right, so today we have already learned this. I want to show you what I'm talking about. If you have f of x is, let's say, 3x plus 5, where x has to be less than or equal to 0, and g of x, we did this yesterday, is equal to the square root of x minus 7, then you know the two domains for f and g. And if you were simply adding the functions, like f plus g, or f minus g, or f times g, you just have to overlap the two parent. Like, you'd have to overlap f and g's domain, and then you'd know what the domain of the new function is. These are my three new functions that I was exploring there. But then we had divide. You remember what was different about divide? F over g of x. Then, yes, this is the extra number line needed where g cannot be 0. Right. So, given that, this is a review, what happened when we got f of g of x? It was totally different, and you needed a formula. Can anybody, without looking at old notes, recall if I wanted f of g of x, what was that formula for the domain of it? Yes, sir. Okay, but you have to overlap that with something. So domain of what overlapped with what? Domain of g. G of x in what? Yes, except it's domain of f. G of x in the domain of f. And it's because we only put it into this part. Okay, so just a quick reminder, this would be a typical problem then. I have to find domain of g. Well, that's easy. I just have to find this, domain of g. And I have to, in a moment, use the domain of f, which was given right here. Yay. Would you please figure out the domain of g? Should only take you a second. And write it right here. And get all of this copied down. And then figure out for me, what is f of g of x? That is a function. And then what is its domain? You'll find that domain by overlapping this with g of x in the domain of f. If you can't do this very last part, that's okay, I'll show you, but at least figure out f of g of x and start by figuring out domain of g, and you'll be halfway there, 3/4 of the way there. I'm going to pause for a second while you do that. Okay, so we've got our function all built here, and we have the beginning of our domain, which is the domain of g. But now we've got to do this weird part, g of x in the domain of f. G of x in the domain of f. So I got to go put g of x, which is this guy right here, and put it into the domain of f, which is right there. So I have to say square root of x minus 7 is less than or equal to 0. Now, can you ever have a square root come out less than 0? No. So then the only thing I'm really looking for is where it equals 0, right? So then what's my answer? X equals 7 is the only thing that will work. Now, could I have done that by using the whole process? Sure, I could have squared this and squared that, and then I'd have to add 7 to both sides, and I would have ended up with x is less than or equal to 7. But that would have implied that things like negative 23 work. And they don't. So you got to be careful with that, because x is just 7. Because the other ones, the ones that are less than 0, they aren't going to work. Okay, so back to x equals 7 is my answer. Just x equals 7. So then when I graph this, x equals 7 is right here. Okay, so where do they overlap? just at 7. So my answer is a set. I could even use set builder notation. Remember this? X, where X is equal to 7. There's set builder. If you want to do it in, you don't usually say from 7 to 7 like this. You just say a 7 in interval notation. And you put it in parentheses or brackets. I personally like the bracket better because parentheses always mean to me doesn't work. Okay. How many of you had that one right? All right. It's okay if you're not awesome at it yet because this whole lesson is all about that. This is just a reminder that the composition of functions is kind of like making Rice Krispie bars. You just take this, a little bit of this, and a little bit of that, and you add them together and you get a Rice Krispie bar. You can take Rice Krispies, you put in a bunch of, what's the gooey stuff? Marshmallows, and then you get these. Well, this is like f of x, this is like g of x, and this is like the one that's been put into the other, right? F of g of x, and I don't really want to have an argument about whether or not you put the marshmallows into the Rice Krispies or if you're putting the Rice Krispies into the marshmallows, because it's kind of irrelevant. But all right, so could you take the answer and say, here's the mix that I have, and break it up into its individual parts? It would be very difficult to do, okay? But you could say, what is this mixture? That happens all the time. They have a, let's say that they have a chemical composition they find on a crime scene. They're going to run it through an analyzer machine, and it'll say, oh, well, this liquid is made up of this and this and this. Okay, well, we're going to do that with functions too. We're going to take a final function that was all put together, and we'll break it up into what the chunks must have been. All right, this is analytically saying, suppose f and g are two functions. The composite of g with f, denoted by g of f, is defined by the formula g of f is g of f of x. See how they're two different notations, but they mean the same thing? They're equal to each other? All right. Provided, this is about that domain thing, x is an element of the domain of f. Okay. So x has to be out of the domain of f. That's the domain of the inside one, just like we said. Remember? And f of x is an element of the domain of g. That's where we say f has to be put into the domain of g. So that brings us to that big formula that I've been telling you for a while now, which is right there, that the domain of f of g of x would be the domain of g, the inside one, intersected with g in the domain of f. All right, we've practiced that enough now that this should be like a review for you instead of new material. All right, now I would like to go back here and say, would you please figure out the blue one here? This, sorry, not just the blue one, there are two blue ones. A. Please try to find the answer to A. While you're doing that, I will regale you with a story about domain names. Because we're doing domains, seems like an appropriate time. I personally own, I don't know, like 12 domain names. Some people would say I've got a habit. I have algebraninja.com. Thought the name was cool, so took it. Only cost me $10. Let's see, what else is out there that I have? davidserver.com, of course. tonkamath.com. I run one for the union, tonkamta.com. It used to have .org also, but anyway, long story. And there's so many different domain names that appealed to me. 2-Minute Teacher was my name of my company, one of my companies. So I took that .com, of course. LongLakeInsurance.com, because I'm an insurance guy, in case you didn't know that. How on earth am I an insurance guy? I guess it came out because when I was first teaching, I basically needed a way to earn some extra money. Coaching wasn't cutting it. I needed more money than that. So I started an insurance agency. And then it grew and grew, and then we started an independent agency. and that grew. And then anyway, I had to make a choice. I really like teaching more than I like insurance, and so even though insurance is less stressful, I really like teaching. So decided to stick with that. Felt like it was my calling more than insurance. So anyway, I have way too many domain names, I'll admit it. Kind of, because once you own them, it's very painful for me to give them up. Another one, call Dave to save. Kind of like that one. My name is Dave. So I thought that one had potential. Another one's DakotaDream.com. Kind of like that one because we have a cabin in South Dakota, and Dakota Dream seemed like a good name for like a place. Well, since then, since we got the domain name, there's been a couple things have popped up that have the name Dakota Dream, and I bet you they would like the .com name. So I'm going to see if I can sell it to them because I really don't need a domain name for a cabin. But if we could sell the domain name to like the state of North or South Dakota and for part of an advertising campaign, that could be interesting. So anyway, I encourage you to buy a very simple domain name, your name, whatever your name is, .com. In fact, take a second right now on Google and see if your name's open. Somebody's already parked a site at yourname.com. That would be interesting news to you, wouldn't it? And if somebody already owns your name, you know, like obviously the people here who have unusual names have a big advantage. But people that have a normal name like robjohnson.com, I guarantee you somebody owns it. Oh, look at that. You have a jewelry site. Congratulations. So how many of you, your website name is open, like there's no site there? All right. Well, you can own it then. You can buy it. Now, it does charge you, depending on the company. Just to clarify here, you don't have to buy a website. You can buy just the name. You can hold just the name and have it go nowhere, but you own it. So don't get sucked into having to buy a website hosting service and everything. You don't have to do that. You can just own the name, and then nobody else can go there without buying it from you. So they're fairly cheap. What does it say? Really? All right. So somebody got there before you. Okay. Yep. I couldn't get mylastname.com either. Server, SURVER, is owned by some company that I don't know what they even want it for, because they're not doing anything with it. But anyway, I encourage you to consider buying your domain name as in your name, and then you own it. You found out that there was a jewelry site or something on yours, right? Can you imagine if it was a porn site? I'm just saying, you can't control what's underneath your name unless you own it. So maybe you should buy it and protect your name. Some of you right now might be the next Britney Spears. You might be. We don't know. It could be one of you guys is going to be a famous actor. You know, Tom Cruise probably didn't know he was going to be Tom Cruise, the movie actor, when he was in high school. I don't know if you ever looked up high school pictures of Tom Cruise. He had terrible teeth.
He still has terrible teeth.
Does he really?
Yeah, they're more like they aren't symmetrical.
Oh, they aren't symmetrical. Interesting. Well, you should see what they used to look like. Interesting. Okay. Let's go back to this. I don't think you did. I remember that bad teeth thing. I don't remember seeing a picture of him. Yes, I do remember that. Okay, the g of x goes into the f of x, and so that means I want domain of g intersected with domain, g of x in domain of f. Stay with me now. I am recording. I was recording the whole time, and it's okay. I think it's okay for people to know that I'm telling you about things like domain names and all that. That's good stuff. You were working on a problem while I was doing it, so it's all working out. D of g is what? Well, that was right here, and it's given. So it's just a number line where x is greater than or equal to 1. Here's a 1, like this. Okay, now, how about g of x in d of f. This, which is really this, into that. So now I go x squared minus 4 is less than 5. Now this, solve it carefully. This is where you are an honors pre-calc student. You can't just, we wouldn't have made it this tricky in regular. What we do in here, solve that and be careful. If you just get one simple little answer, you screwed up. Now I'm going to pause for a second while I get attendance done with some other stuff. Here, let's see if you did this one right. Did you add 4 to both sides and get x squared less than 9? I think most people get that. Square root. And now, do you still fall into this trap? Yeah, got to remember its absolute value is less than 3. And that'll give you your 2 answers. Be careful on this part. Did you say x is less than 3 and x is greater than negative 3? You have to switch that sign. Why? Well, this is like multiplying it by negative 1. 3 turned into negative 3. That's what the function is effectively doing. And so when you multiply by negative 1, do you remember you have to switch the sign around? Okay. So then, the final answer for this is, where do these overlap? I'm now going to graph. Here's x is greater than, oops, I need that to be an empty circle. X is greater than 3, and x is less than negative 3. It's like this. And now, where? Greater than negative 3. Sorry, my bad. Undoing. Okay, so here's 3. Here's negative 3. And I go between them like this. Okay, there we go. Now, where do they overlap? They overlap between 1 and 3, where it works at 1 and it doesn't work at 3. So 1 bracket to 3 parentheses. That was about as tricky as they come. Is there any part of this that you want re-explained? I'm willing. Yes? You would flip the sides. Okay, so imagine for a moment I had this. Usually we have the x in the parentheses. That might even mess with my head. Let me just back to this. Okay. So then, you always, when you have absolute values, end up with 2 answers, right? And the first answer is always just recopying the problem without the absolute values. X less than 5. And then the other side is always exactly the same, except for one of the numbers changes to the opposite. The answer changes to the opposite. So x is less than, but as soon as this changes to negative 5, it's like I'm multiplying by a negative 1, and therefore I have to reverse the sign. X is greater than negative 5. That's another example of that. Okay, well, let's move on. So here's our big formula again. You got to have that under control or you will get a bunch of things. Well, today's assignment will be a complete disaster without that. I don't think we need to do tons of practice problems because we did them yesterday. So I'm going to jump on to, research has shown that when you are going to be learning something in the future, if you can just kind of touch on it the day before, let your subconscious start working on it, that it gives you a big advantage. So you are going to be learning for day 2 about decomposition. Decomposition. It's not just for dead bodies anymore. Decompose, means to break down, right? So if you had I don't know, somebody runs over a weasel out in the road and it lays there out in the sun for long enough, eventually kind of decomposes, right, into its base parts. Well, let's say that you have a big function like f of g of x, and it is 2x squared plus 3 all over 7. That is the combined function. How can we break it down into its parts? What was f of x? What was g of x? Here's the way to think of it. First of all, there is no one right answer. There is multiple right answers. So, do you get that some piece of this function got put in there I'm going to say that this piece right here is like, it's a natural divide line. It's a natural place to pull something out. So I'm going to pull out that and say, I want that to be like g of x. That's the thing that got put into the other function. And if I pull that out, what had to be there in order for us to put it there? There would have had to have been a 2x over 7. There would have had to have been x right there, so that when I dropped in the x squared plus 3, that it would have had a place to go. All right, so moral of the story is the g of x is you pull out a piece of the function that has the x in it. It has to have the x in it. And then I chose this time. And then you logically figure out, if you remove that from the equation and replace it with an x, that the other part must be f of x would have to be 2x over 7. Now, that is one way to answer the question. I would like all of you to find a different way I could have done that. G of x could have been something else. It has to include the x squared. There's no way to avoid that. I have to pull that x squared out, and that has to be part of g of x. But there's several other options. Try to figure one out. What's another option that takes out either more or less than the x squared plus 3? Okay, so you should have tried something like pulling out the whole top, maybe. If I said g of x is 2x squared plus 3, then if I pull the whole top out, what do I have to replace it with? An x, and then f of x would have to be just a big x on top over 7. The proof is in the pudding. You've probably heard that before, and I really don't understand where that saying comes from. But if I take the two things I think work and I put the one into the other, I can check if it works. It's really not that hard. If I take this and I actually put it in right there, I will get the original problem right here. So I'm doing it right. That's called decomposition, and I'll tell you more about that tomorrow. How many of you had a different way that would have worked? Okay. I don't expect you to learn that all right now because you don't have to. Now let's look at your homework for today. I want to show you which problems I want you to do and which problems we can skip. It starts right there. And some of these have required and then challenge on them. It's really not that complicated. Just do every problem that doesn't say challenge. Okay, so don't worry about requireds. They're all required unless I tell you to skip them. So I think this is a little long, so we are going to skip a couple. I'm going to have you skip problem number 5. And, yep, and then problem number 13 is a skip. And these are those ones where you're doing like f of g of x. You also need to find the domain. Notice here, it's not on the same page. The directions are here, but the directions go for 13 through 24, which basically means 2 pages in a row. You do need to find the domain on these. Again, we're skipping number 13, but for 16, 19, and the ones after it, 21 and 24, make sure you find the domain on all of those too. All right. You'll start to get good at them. They really don't take very long to do. So, and that is it, because then that starts day 2. So as soon as you hit this purpley looking slide, that's tomorrow's homework. Okay, so let's start this together, and I'll show you it's not too rough. This one, g of f of 0. I like to write it this way. So I'm going to start with finding f of 0. This is stuff from higher algebra last year. Should be piece of cake. F of 0. So here's the f function. I put in 0, and what do I get? 0. So then this whole thing turns into 0. Now I'm finding g of 0. G of 0, I put the 0 into that function, and what do I get? There you go. That's it. F of g of -1. F of g of -1. So really, you got to start with the g of -1, right? G of -1 would give me -2 plus 1 makes -1. F of -1 then, go stick the -1 into that function. -1 squared is 1. All right, if we were worried at all about the domains of it, which, by the way, it doesn't mention the domains at the top, but it does say something ominous, if they exist. Okay, so this is all reals and this is all reals, so if I'm just doing add, subtract, multiply, and divide, add, subtract, and multiply, then all reals overlapped with all reals means all things work, so you can't have something not work. Down here, it's all reals. That one is x has got to be what? Greater than 0. Okay. So if you were asked to do this one right here, you get how as soon as you do g of -1, the thing's going to crash. So then you can just stop right there and go, oh, the answer is no solution, or anybody know what that means? DNE does not exist. Or if you live in my neighborhood, Derek Nico Excavation. That's his company is DNE. So I don't know if he knows that means does not exist. But all right, moving on. Number 11. F of g of 0. That's the same exact process. This shouldn't be too tough. G of f of 0. G of f of 0. So I got to do f of 0. So I put a 0 in here. Does that crash my function when it makes the top 0? No, it's just a 0. It's only if the bottom would be 0 that I'd have a problem. And now g of 0. Same thing. Put a 0 in here and doesn't crash my function, so I just get square root of 1, which is 1. There we go. All right, so these first few are extremely, or it should be extremely easy. And you know what? They're easy enough. I'm going to have you skip another one. Why don't you skip number, I had you skip 5, right? I think you can skip 9 also. Skip 5 and 9. Okay. And then these are the kind where you end up needing to find the overlapping domains stuff. Both this page, 16, 19, and 21 and 24. That's the real like R3 kind of level questions. The other ones would be more like R2s. Okay, and that's all I have for you for today.